Okay, so we went over high-level view of Condor, and now let's go over with the high-level view of the glideinWMS, since this is about glideinWMS training, not Condor training, although you will see Condor is pretty important. So, as we said, Condor is composed of three pieces: submit node, central manager, and a bunch of execute nodes. And nothing magical about it. Now, when you go to the glidins, what happens is you essentially replace the dedicated execution nodes with opportunistic execution nodes in the grid, and you call it the glidins. So a glidin is really just a properly configured execution node that is submitted as a grid job, and you can replace grid with cloud or anything else. Essentially something that is not dedicated, but you get there and you get it for just a certain amount of time. So what's glideinWMS? Well, glideinWMS is just an automated way to submit glidins on demand. That's about it. So we put this additional box here that actually goes through the various grid middleware layers like Globus, Cream, you name it, and get the gliding on the worker nodes so that it can start in and the usual Condor magic happens. That's about it. Nothing really more complicated than that. So with a little bit more of detail, the glideinWMS architecture has really three pieces. It has a front-end node, which is part of the front-end domain, and it's together with the rest of Condor, what VO maintains. You have a factory, and you then actually have something that does the configuration on the worker nodes themselves, called the glidin startup script. And we will go into a little more detail in this talk about these three different pieces. So let's start with the glidin startup, which is the one that configures and starts the Condor execution daemons. And this does the runtime environment discovery, validation on top of the configuration. You have the factory that knows about the various grid sites, cloudish style, whatever, and does the actual submission of the glidins. So this is where the grid knowledge and troubleshooting resides in the glideinWMS. And then you have the front end who knows about the user jobs and actually requests the glidins. And so it has the site selection logic and does the job monitoring. So these are the three main pieces of a glideinWMS system. And we will refer to this all along for the next 2 days. Before moving forward, let me stress that there is an end-to-end relationship between the different pieces. Each front end can talk to many factories, and each factory can serve many front ends. While you can have situations where you have one-to-one, maybe handled by the same people, that's an exception, not actually the rule. So you could have two VOs, for example, a red one and a blue one. Each has its own collector SCD negotiator, its own front end, and they can, for example, share a factory and go to the same sites or to different sites. But they are effectively distinct systems. So there is no such thing as a glideinWMS, really, as a single system. It's many pieces that work together in order to achieve what you want. This brings us to the next slide, which is that you really have multiple operators. The factory in the front end services are typically operated by different people. As I said, there may be exceptions. There are a few exceptions. The front end VO is VO specific and it's operated by the VO admins. And you set the policies of your users, whatever you know your user needs, any customization, it's done there. And while the factory is generic, it's really there, it's not affiliated with any group. And its main operation task is really grid monitoring and troubleshooting. Yes, we will discover which sites are available, but that's sort of trivial part. The real operation heavy part is looking after what's going on in the grid interfaces, troubleshoot any problems and solve them so that the VOs don't have to. And since many VOs go to the same sites, the economy of scale really kicks in and helps a lot. So let me go through the various, the three elements one by one, and give you again a high-level view of how they work. We'll have more details in the future talks. So as we said, the gliding startup is the part that actually configures and starts Condor. It does a few things. First of all, it validates the node, essentially the working environment, stuff like do I have any disk available, do I have any networking, is the BIOS software available, blah blah blah. It gets the Condor binaries. We don't rely on Condor already being pre-installed on the machines for two reasons. One, it may not be there because the grid site may not be using Condor as a back system. But more importantly, we want to have the Condor version we want. So the site may run a version of Condor that is not the one we need, and we don't want to just get whatever we can get when we can get what we really need. So we actually deliver the Condor binaries to the worker node and run what we need. It does the Condor configuration, it starts the Condor daemon. At that point, Condor runs. The gliding startup is essentially dead, waiting, zombie, whatever you want to call it. And once Condor is done, it collects some post-mortem monitor information and does the final cleanup. It's a good citizen and doesn't leaves craft behind, as much as it can, of course. So, the gliding startup per se is really just empty shell. It's there just to do everything, get the scripts that do everything else. The reason for this is that in some grid cases, you really cannot send large input sandboxes. You really want to keep it to the minimum. So the glideinWMS was designed in such a way that a very small script is sent to the worker node, and then everything else gets downloaded on the fly. This allows us to be very flexible. And the files and configuration scripts allowed via HTTP, so that you know, and which has a nice property that can be cached if there's the local squid available. And it gets both from the factory and the front end node. So as we will see in more details later on, the front end can provide validation scripts that are BIOS specific. And factory will provide scripts that are generic and meant to be the same for all the VOs and provide basic functionality that a gliding needs, including doing the configuration, setting up GLXX, etc., stuff like that. And the mechanism is tamper-proof and cache coherent. So you don't have to worry that just because it's HTTP, which by itself is insecure, you risk that somebody will hijack and run arbitrary code in your name. So the scripts that come, as I said, there's a few standard glidings, plugins that come from the factory, and this is the basic grid validation, like are the certs available, is this available, and stuff like that. Does the Condor setup, GLXX, CCB, starting Condor. But VO can provide some plugins, completely optional. You don't have to provide any. You can run without any if you want. But they are nice to have so that you can avoid problems or set the environment for the users so that it looks like your local cluster, for example. For example, CMS at UCSD checks that the CMS software is installed. Basic validation stuff. The factory administrators provide them, go into that, and there are more script details here that we have a complete talk about them. So this is just 10,000 feet here. The second part is the factory, and we said the factory is the part that knows about the grid and submits the gliders. So it's here. Actually does the submission. And the factory knows how to submit to the site because it has a list of local configurations. So the factory will not submit to any site under the world the factory admin actually are supposed to validate and make sure a site is trusted before submitting there. It can get information from the various grid information system, but doesn't need to. I'm not going to tell how, for example, the OSG line factory is configured, but just so you know what to expect. And for each site, which by the way is called entry in gliding entry in the glideinWMS terminology, so when you see entry along the docs, you know what I'm talking about. Has the contact info, for example, node, the grid type, job manager, blah blah blah, whatever you need to actually get to the CE. The site configurations, stuff like where to start, is this GLExec supported or not, what kind of OS type is available, and whatnot. Which VOs are supported in the OSG gliding factory. This is what is supported VOs? What is the name? Yeah, gliding supported VOs. And any other attributes like the site name, what is the closest SE, you name it, anything can be done. It's completely arbitrary, and each factory it's sort of free of doing whatever it wants. Of course, it's good if people agree on things, but to the first approximation, anything can be there. And all this information is being maintained and periodically compared to PDII or any other information system for the specific grid type. So what is the factory role, right? We've seen it's one of the three pieces. So the factory is really just a slave. It may seem weird, but it is really the slave. It knows where to submit, but it will not submit by its own. The front end tells how many glidings to submit where. The factory will not do anything by itself. It's just a passive subject. And once the glidings start to run, they report back to the VO collector, so the factory is not involved at all. So the only thing that the factory there is to receive order from the VO front end and submit glidings. That's about it. And then it's out of the picture. The communication is based on class ads, so the factory really has a collector running alongside, and the front end actually sends class ads to the collector that the factory will read, and this is how the commands verify. Don't remember right? I explain here. Yeah, a little bit. So the collector is really the central point where all the communication is exchanged. So all the security is also implemented here. The factory with the various daemons running here and the front ends don't really have any listening ports. It's all outbound connectivity to the collector. So all the security, all the access control is controlled here, which has a nice property that you don't have to worry about security too much about security bugs in the various daemons, because if it doesn't pass this one, this will never see it. So it's a good first line of defense. Now, it's true that the factory is a slave, but it's a slave that decides who his master is. So the factory admin decides which front ends to serve. So it's not that like we will serve anybody that comes along, but the factory actually whitelists all the front ends that it will be serving. And the authentication is based on X509 GSI proxies, standard stuff. And it's the DNs are whitelisted, essentially. There are some more fine-grained controls that the factory can do to make sure that if we have a malfunctioning front end that did something weird for a single site, we can blacklist it for a single site, but that's way too much detail for what you care. Just so you know, it's there. But really, you will have to have a proxy in the front end in order to talk to the factory, or the collector will turn you away at the door. And yeah, we'll have more details about the front-end protocol in a different talk. So, a little bit details about how the gliding submission is done in the factory. So, as I said, glideinWMS is all about content. And submission to the grid is also done through Condor. So Condor G is used to submit the glidings to the various grid types, including cloud types. So if Condor G submits it, supports it pretty much, the glideinWMS supports it. If you want to go to something that Condor G doesn't support, talk to Todd, because we cannot help you. And Condor G is really the one that does all the work. The factory just submits to the SCED, and then it's a Condor G, the SCED, that does all the magic, and the factory really just monitors it. So if something is wrong, talk to Todd, because it's Condor's work.
I'm finding out why you're asking.
It's working great, but yeah, if you want something beyond what's available, yeah, it has to go through Condor. We actually cannot do anything if Condor doesn't support it. We are really tied to them. And as I said, it worked great, so we are happy about that. So, you know that if you submit to the grid, you need a proxy, a credential, and the proxy is typically provided by the front end. So while the factory itself submits the glidings, it has to get the proxy from the front end. Although the factory can provide a default one, but it's usually disabled. It's really used just for testing. The delegation from the front end to the factory, it's done in a class add. Everything is class add, but it's encrypted, so it's secure enough. And the factory will provide the encryption key, so that's taken care of. And the proxy will then be stored on the disk. And so to make sure that different, since a factory can support multiple VOs, multiple VO front ends, each VO front end will get its own UID assigned at the factory, and the proxies will be owned by different UIDs, so you have system level protection between proxies. So even though a factory node may host proxies from multiple VOs, unless there is a security compromise of the whole machine at the root level, they are protected against each other. So don't worry too much about that. And that's all I have about the factory, and you will not hear much more about it. If you really have questions, we can discuss this offline, and Jeff knows a lot and can help, or you approach me. So the third part, the front end, which is really the core of this training, is the last part, and it's the one that actually does the matchmaking and requests the guidance. So, as I said, it's the brain of the glideinWMS pool, and it's really a site level negotiator. It will monitor what's available, both in terms of which glidings already are there and what jobs are still in the queue, and decide if there are any waiting jobs that need more glidings at certain sites, and decide to request more glidings to the factory. The factory then does the actual submission, but the request comes from the front end. So, which brings us to the next thing, that we really have two levels of matchmaking in the glideinWMS. The front end will decide that more glidings are needed and trigger the submission of the glidings to the sites. But once the glidings start, they talk to the central manager, and the final matchmaking between jobs and machines is done by the negotiator. And the two don't talk directly to each other. They should be configured similarly, but they're two completely different processes of working on their own. So we will get to this a few times in the talks between today and tomorrow, but this is really important to understand when you both configure the front end and when you try to figure out why things don't work. So, a little bit about the front end logic. The glideinWMS gliding request logic is based on the principle of constant pressure, which means that the front end doesn't ask for 3 glidings or 10 glidings. It asks for a certain number of idle glidings to be pushed to the site continuously. So essentially, it says, I need 3, I want factory, please keep 3 idle glidings in the queue, and as soon as those start, submit more, I want this amount of idle glidings in the queue at all times. So this allows us to work in this completely asynchronous mode where the daemons don't talk to each other and have very little communication between the factory and front end and still make things work. So essentially, typically if you have a lot of jobs in the queue that can run on a site, it will say something like, give 20 idle jobs in the queue until you tell something else, and the front end can pretty much go away at this point, although it has to continue updating the class ads, or the collector will drop them and the factory will assume that the front end is gone and stops submitting more. But the factory will continue to submit the glidings and keep the pressure. Once the front end starts to notice that I have only a few jobs in the queue anymore, it will reduce that pressure point to something much lower, for example, down to 1 if needed, so that only a small trickle goes through, and the moment I don't have anything more that needs to be run, it will return to 0 and no more glidings will be turned off. So this is how it works. And as I said, it's due to the synchronous nature. It allows us to be complete, only from time to time talk to each other and still be very efficient. Right. So the matchmaking works to a certain degree similarly how the negotiator does. It matches jobs attributes against entry attributes. So essentially the factory entry is like the resource in the Condor. But instead of doing matching one-to-one, it does one-to-many. So essentially for each job, it finds all the entries that match, or it's the way around actually. For each entry, it finds all the jobs that match, counts them, and then uses that to calculate the pressure point, which is typically a third of that and then capped to something like 20. And the other big difference compared to what's done in the negotiator is that the jobs themselves, or the entries for that matter, don't have requirements. The requirements is centrally defined in the front end itself. Consider it like having a requirement in the negotiator itself. Instead of having it in the class ads, it's the who does the matchmaking that actually has the match expression. And so definitely the users cannot do it. And it can be debatable if it is better or worse, but it definitely reduced the front end complexity, and this is the initial reason why it was done. But I actually like it a lot at this point in time. So I would actually like Condor implementing something like this. As I said, the front end owns the gliding proxies that are delegated to the factory, so that the factory can pass this proxy to Condor G to actually submit to the grid. And you must make sure as a view administrator to keep it valid at all times. So since proxies are short-lived, you have to continuously update them. How you do it, it's your business. Use a cron tab, use my proxy, whatever works for you. It just must be valid at all times. And it must be valid for at least the lifetime of the gliding you will be submitting. So if you expect your glidings to last for 3 days, the proxy must be 3 days long. Or the gliding will shut down the moment the proxy terminates. And we don't do renewal, disable renewals on the glidings. So it must be the moment the gliding starts up, whatever is left on the proxy, that is the maximum lifetime of the gliding we will support. The VO frontend can and should provide VO-specific validation scripts, so that you will test for something like is your VO software installed, or do some other manipulation of the environment for the user jobs. And the VO frontend can and should set the gliding expression so that the VO negotiator can actually work fine, and you don't have to ask the users to do the proper requirements. Yes?
In this administrator provided start expression, it can reference attributes in the entry and in the job?
It can reference in the gliding and in the job, of course. Most of the attributes that are in the entry gets propagated in the gliding class app. The gliding is just a starting, right? So a machine class app will have most of the attributes that are in the entry. the admin decides what's propagating, what not. You can propagate everything, you can propagate nothing. Usually what you use for matchmaking you should propagate. And use those same attributes. Because you want to have the requirements in the gliders to be as similar as what you have in the matchmaking expression in the front end. Or funny things happen. We'll talk about that tomorrow. But yes. And this is pretty much about it. Just few take-home messages. Glidings are just properly configured Condor execute nodes submitted as grid jobs. There's no other magic about it. It's just standard Condor, just somebody needs to start it up on a grid worker node. The glideinWMS is just a mechanism to automate gliding submission. Again, nothing fancy. We just built something to automate it so you don't have to type Condor gliding by hand. Condor actually supports submitting glidings by hand. It's a lot less fancy than what we do, but you can actually do it. You don't need the glideinWMS to do that. But it's convenient. It does a lot of things for you, so you turn it on and forget pretty much about it, for checking that things actually still work. And another thing to remember for the rest of the talks, because we reference it a lot, the glideinWMS is composed of 3 logical parts. The gliding and 2 are actually services, the gliding factory and the PO front end, and then you have the gliding startup scripts. And I think that's all I have. Yeah. So just pointers if you want to see anything.